My area is environmental fluid mechanics, and I apply that to water quality models. So the idea is to use the understanding of fluid physics to figure out where pollutants are transported and how they're transformed in the water environment. And one of the major areas that I'm involved in is multi-phase plumes. That's fluid motion that's set in motion by the buoyancy of bubbles, droplets, particles. And an obvious application of this recently is the work with the Gulf of Mexico oil spill. If the oil and gas are positively buoyant as bubbles and droplets, and if the ocean were quiet, these hydrocarbons would simply rise to the surface and things would be well understood. But the ocean is stratified and there's currents, and these cause the dispersed phases, the oil and the gas, to separate from the entrained water, and that causes them to take different trajectories to the surface. In fact, some of the oil and gas never made it to the surface. And models like we've been developing have helped to explain what's in fact happened there. Well, so as luck would have it, we had done some work back in the year 2000 that related to this and helped explain where oil and gas droplets and bubbles would go in a spill very much like this, and that was called upon to help explain where the oil for the BP spill ended up. One of the things that happens when the oil and gas are released is you get a wide spectrum of bubble and droplet sizes, and this is especially the case since they use chemical dispersants at the seafloor. And this was actually the first time on any realistic scale that dispersants had been applied at the subsurface level. So people weren't quite sure what was going to happen, but a lot of the oil was dispersed into fine droplets that made their way very slowly to the surface, and some of them were degraded and dissolved before they reached the surface. And so that was a finding. One of the ways that the authorities originally estimated the magnitude of the spill was to look at what they could find on the surface. And what they found on the surface, especially within a reasonable radius of the wellhead, was only a subset of what was discharged. And so that was one of the reasons that the initial estimates of the oil spill volume were way low. They neglected all the oil that was residing underneath the surface. So we have models that help predict where that went, and they showed that a lot of the oil was trapped at a layer around 300 to 400 meters above the bottom, and this was later confirmed with lots of measurements. One thing that we need to do is to have a better idea of what happens when you put chemical dispersants in an oil spill at depth. Back in the year 2000, there was a wonderful field experiment that we played a minor role in called Deep Spill, and there were actually 4 experimental releases of oil and gas off of the coast of Norway. And these were monitored with all sorts of instrumentation to find out where the oil and gas were going with the purpose of helping inform models. And it's unfortunate that that research kind of stopped 12 years ago. It would be nice if there was a 5th, a 6th, a 7th experiment, and that some of these additional experiments involve chemical dispersants. I think that's the next step. There's still a legitimate question of how effective they are, how small the droplets need to be in order to remain dispersed in the water column, what the environmental impacts of the dispersants are, what quantities, dispersant oil ratios are needed. A lot of that is being addressed through experiments in the lab, but ultimately we need a field experiment to validate some of this. The best partners would be folks in the oil industry. They know most about what's going on. They were largely involved in this earlier study, the Deep Spill study. This was a marvelous study. There were something like 22 companies that grouped together along with the U.S. Department of the Interior to co-fund these studies. So that's where most of the expertise lies. It's a question of getting people together. And that's happening now because of the BP oil spill. I think the climate has changed at this point so that the oil companies are very willing to come to the table. There are a couple of legal cases outstanding, but notwithstanding, they basically have a shared interest in this. Nobody wants this to happen again, and this is likely to result in a lot of good collaboration. The American Petroleum Institute has several subcommittees that are funding research into these areas. BP has funded a lot of work. The Department of Interior is funding work. So belatedly, a lot of this is taking place. So hopefully we'll know a lot more before the